Hi, Beckton. Looks like we got our first customer.
Hello.
Hi. I think this is the first time you've dropped in. Is that correct? Have you been in earlier? Okay. Can you hear me?
Yes, I can.
Okay, I can hear you, so that's fine. I'm just saying, is this the first time you've been to a Zoom meeting with me?
Yes.
Okay, so have you had a chance to join WebAssign and get started on it? Great.
I did that yesterday. Yeah.
Great. Have you been to the Canvas shell to look at the videos and all the things that you've missed over the last week or so?
No, I haven't seen that. Would that just be in Canvas or?
Yeah, in your Canvas class. So if you go there, you'll find that I have a Canvas shell, and in that Canvas shell, you'll find the videos from last week,
Okay.
which went over the topics that were covered then. Okay. This particular class is a little bit different than the other ones. It's asynchronous, which means that there isn't really any fixed times, but I picked this time hopefully in order that you would at least have one opportunity to come and see me and talk to me in case you have issues with homework, and so I could go over some of the topics as well. So that's kind of what my plan is, but we'll see how this goes. If the times I've given are not suiting people, then I do have alternate times as well.
Mm-hmm.
So I'm going to open up that same shell. We're still quite early, so there's a good opportunity for people to turn up. So this is ours. This is what you should be seeing, which is this.
Yeah.
Right. So over here on the left is our syllabus.
Uh-huh.
And if you're looking, for instance, I said, look, you've missed some videos, you've missed a whole week of them. If you click on class Zoom schedule and videos, as I am, what you'll have here are the links to the 2 time slots I've got specifically for this class. But if those times don't suit you because of your work schedule or other classes interfere with it, then I have, as you can see here, 3 alternate time schedules where you could turn up in these time slots as well. So if this particular time slot doesn't work so well for you, you could certainly turn up for Monday, Wednesday and Friday instead of the Tuesday-Thursday combination. So I don't know if Tuesday works, right, so we're good that way. If you then scroll down a little bit further, it's a bit hard to Zoom. I don't always know what you're saying. Are you seeing week 1 recording, week 2 recording on the screen I'm showing? So you see, right, so if I click on week 1, do you see 4 videos? Or I may have to go back out and in to make that happen. I'll try it. I'll go back out and I'll go back in.
Yeah, I see 4 videos. I see 4 videos.
Right. And can you also see them on my screen, the one I'm broadcasting? Right, so yes. These are the lessons that you could go back and have a look at.
Okay.
And your job is to get that, is to catch up. You also have to do a whole load of homework in WebAssign, which is here. And you've just joined that yesterday.
Yes.
So the homework that you need to get done for this Sunday by midnight of this Sunday, which is the 4th, is chapter 1 and chapter 2 and getting started with WebAssign, which is this one here. So you've got this group of homework questions that you need to get completed. So we've got another person coming in. So on that site, the Canvas site, you'll also find, if I return back to the main screen, you'll also find chapter 1 getting started and chapter 2 organizing data. You'll find that I've got resources there. And when you click on these these give you things like other people's videos from members of the faculty at Olympic College and other locations. PowerPoint on the 2 chapters. So if you want to look those over, if you need, and some notes, which are my notes, basically covering some of the key points. So there's tons of things, hopefully enough that you will feel that you're not left on your own devices and you've got some backup.
Yeah, sounds good. Thank you.
You're welcome. So, Derek, I saw you just arrived. Can you hear me?
Yes, sir.
Good. You're a little bit quiet. I don't know if that's a feature of your mic. If you could turn up a little bit, it would help.
Yeah, can you hear me now?
Yeah, I can hear you much better now, thank you. So, is this the first time you've been to this class, Derek?
Yes.
Okay. So, Beckton knows all about it because he was here a few minutes. He was a few minutes earlier. So, what I suggest you do is that sometime tomorrow, when you go to the Canvas site, you'll be able to watch this video. And at the beginning, the first 10 minutes or so, or 5 to 10 minutes of this video, you'll be able to hear what I said to Beckton. And that way I don't need to repeat myself. But if someone comes in the next 4 minutes, I may have to repeat that sentence to them. So, just so it's going. So let's get used to each other. Why are you taking stats, Beckton? What's the reason you're doing this class?
Yeah, so I just need to, this is my last class to get my degree. And
Okay.
then, but I just don't want to take a normal math class. I want to take a business math class or somewhere in that field.
Okay.
So, yeah.
So if you pass this class, that'll be your math box ticked for your associate's degree, right?
Yes.
Gotcha. Derek, what are you taking this class for? What's your reasoning?
I'm going into the nursing program hopefully in March, April.
Gotcha.
It's kind of a prereq. One of this and anatomy are my last 2 really.
I hear you. It's pretty common. A lot of the students I get, especially in the summer core, but not necessarily just that core, are people in the medical thing, the nursing program, or something to do with the medical field. So you're a pretty typical kind of student for this class. Hi, Gary Young. How are you doing? Yep, she's still getting her audio sorted out, I think. Gary Young, I don't know. Can you hear me yet? Hi, Chris. You're through. You're doing good. You come through pretty smoothly.
Yeah. Well, I use the county fiber, KPUD.
Oh, so you got a good bandwidth.
Gigabit, full duplex. Yeah.
Oh, God, you'll be able to stream movies and who knows what else on that thing.
Well, I wouldn't be surprised if Olympic College uses the same network.
Yeah, mine is being broadcast from my home, but I had to fork out a lot of money for unlimited on bandwidth gizmo thingy. So hopefully, I can certainly cope with the bandwidth as it's happening. Some of our students, unfortunately, don't get great reception or can't afford, I can understand that, really good internet connections. So it kind of hit and miss. In this area, it's kind of hit and miss. Some of the places don't have a great deal of options.
Yeah, I know. Especially like companies like Comcast, they're kind of like cartels, like Wade, Comcast, in that they have certain sections of the county that they are the sole providers for, and they rarely overlap.
Yeah. Yeah, I'm Comcast, so I hear what you're saying.
Yeah.
Yeah, this
Yeah.
area is pretty well saturated. I do maintenance repairs for Comcast on aerial cable. That's what I do right now.
Oh, cool.
Okay. Oh, Derek. Yeah, Derek. Could you turn your audio up just a little bit? If it's hard for me, it may be hard for others. Plus, I'm getting old, so I probably need a little bit extra decibels that maybe the others don't. So I'm just doing a head count. So we'll wait a few moments. Gary Young, I'm still waiting for you to get through. Is your baby causing you trouble? She's got a new baby.
That's tough.
Yeah.
In my mother-in-law's house, so I just put the mute.
Oh, okay, I got you. Right. So is the baby being looked after by your mother-in-law? Is she taking it off your hands for just a little while? Give you a break?
Yes, she's taking a nap right now.
Well, that's good. Enjoy every minute that you get. Courtney, are you up and running? I haven't had anything from you yet, so I can't tell if you've got.
Yeah, hi, I'm here.
You are here. You sound kind of depressed, but you are here. That's good.
Oh, I'm ready. I'm ready.
That's the attitude. You're ready to take the world on, right?
Yep.
Good. Okay. We'll just wait a few more moments. There might be one or two stragglers, and then we'll get started. Okay, I just got your message. When you text me messages, everyone, it's kind of difficult just to be my setup is I don't directly actually see them. I have to go out of my first window and look at them and then back in again. So that's why I was picking on poor Gary Young. I didn't know that she'd already texted me that she had to put it on mute. So I got you. So a little bit late in the day, but I did get your message, Gary Young. Okay, let's. I want to change my mind. I was originally just going to ask you to watch the beginning of this video where I was going to share some information, but I think there's enough of you here and it's probably just quicker if I spend a few minutes showing you what is out there. The first thing I'm going to share with you is our Canvas site, which you should be looking at now, Math 146, and our section is 125.44. In this site, what you get is a whole load of different resources. So, for instance, if you are having some issues with you don't have good technology, if you click on this link here, technology resources and services available, you could get, for instance, a borrower of a laptop with a webcam on it, for instance. You can contact the mesh office and borrow a calculator for free, a TI-84. You will need a TI-84 calculator for this class. We're going to be doing a lot of number crunching next week where you'll need that calculator. The first 2 weeks you could get by without it, but you will need one. So contact the mesh office, MESH. I think you'll be talking to Cheryl, and she knows all about it. She'll arrange to, come to the door and hand you a calculator. There is an alternate way to do this. If you click on this link, let me assume, are you seeing what I'm talking about? Because I have to go in and out a lot with this thing, right? I have a TI-84 emulator, which I sometimes use. So if you click on that, it works on the PC. It's hit and miss if it'll work on an Android device or if it will work on an Apple device. I've had students who've told me in the past it worked fine and others who said they just couldn't get it to work. It might be the go-to thing because at least if it's just a piece of software, you can run it. If you want to see what it looks like, let's do a little side issue here. I'll click it right now. I don't know if you can see it. Can you see it right now? Right. It just looks like, yeah, it just looks like a TI-84 calculator. And if you hit an on button, you can go 8 times 9, and there you go. So the link to it is this link here, TI-84 emulator. So you click on that link and it'll take you to a site where you can download the software, and I think you have to do some other things. Chapter 1 and Chapter 2 is what should be done this 2 weeks. So we only have, we're into week 2 now, so you've got until Sunday midnight to get all the assignments from the first 2 chapters, 1 and 2, completed. And these 2 give you, they give you help, essentially. So if I click on this one, there is no homework on this. There is no homework on Canvas. Everything is in WebAssign. Canvas just has resources to help you. So if you click on this one, can you see Chapter 2 lessons, yellow and faint blue, right? This top one contains various videos and various topics that are covered. And it contains the Zoom lesson for this class. If you scroll down to, say, the bottom, here are some notes. If you go to the middle one, here are PowerPoints. So I have that for both chapters 1 and chapters 2. Let's see if I can get back. What else do we have here? Chapter 2, as we say. If you want to go and look at other videos that have happened in the past, then you click on Class Zoom Schedule and Videos. When I click on that, it'll show you the Zoom links. This is one you've just used right now. And this one will be the one that you'll use on Thursday. And here are alternate ones, because I have a second 146 class. So you can actually look at them. And down here, here are all the videos from the first week. So if you weren't here in the first week, or you didn't get a good head start, you can watch these videos and you can see the lessons that you would have missed, and they might help you get through your homework as well. So there's, again, hopefully you're not being left to your own devices, right? There is lots of things we can do to help you out. What else have we got here? You need to enroll in WebAssign, and it's a piece of software. It costs money. You get 2 weeks free, but at the end of that 2 weeks, you have to pay for it. Right now, you need to get on that as soon as possible, because that's where you'll find all your homework. If I now click on this one, here is your homework. This is part of WebAssign. You do not need a textbook because it has an electronic book, so at least you don't need to pay for a textbook. If you've where was I going? Right. You need to follow the instructions and get into this straight away, essentially. I don't know how you're going to pay for it if you're in need, but there is a CARES grant still around, so go onto Olympic College website and see if you can get some money off them. I believe it's 500 for 5 credits if they award you, 1,000 for 10, and 1,500 for full time. So that's one way of getting resources. There's a link in my Canvas site to Sing, and so you might contact them if you're in financial hardship. They again may help you. But essentially, WebAssign does all the homework. That's where everything is. And it's basically you get questions and there's boxes to put answers, and that's how it works. It has other videos to help you. It has worked examples to help you. It's got tons of other resources. So that's yet one more place to go. So you may actually have too much stuff to look at. So you might have to be selective about what you need to look at. I mean, if you can do the homework and it's making sense, then you probably wouldn't need, I can move this thing a little bit, kind of in the middle of my face. There we go. You can do that, right? You can just choose what you need, or as much or as little as you want. If you have any problems, we have e-tutoring. So it's totally free. You can click on that and you can get a Zoom meeting with a tutor and they can walk you through whatever the homework question or the problem was. You can certainly contact me. You just need to shoot me an email and we'll try and figure out a time. This meeting right now is one of those opportunities. So I think what we might do is, once I've finished all this spiel, is we'll ask, is there any homework questions you'd like me to go over first? Right, and I'll do that. And then once that's finished, I'll use the rest of the time to talk about the topics that we haven't covered and that are going to happen in the later sections. A lot to take in, but remember, it's all saved in a Zoom meeting, so you can always go and watch it again and pause and rewind and pick up anything that I might have said. So, do we have any questions right now? Anything about what I've just said, at least? Is there any homework questions you would like me to go over right now before we start kind of the normal class lesson process? It's okay to have none, but if you do have one, it's also okay, right? So I don't mind. One way or the other, I'm cool. Okay, we are good to go then. I am going to start chapter 2. So chapter 1, you'll have to go and look at last week's videos and do that. If I do chapter 1 this week, then I won't have covered chapter 2 and we're in the same boat, right? So I have to make a commitment. There's nothing in chapter 1 that you need to know to be able to do chapter 2. It's quite isolated, so it's not like you're in real trouble. And we'll look at frequency distributions. And I'm just getting the homework thing set up so I can look at these guys. There we go. So this might be a little bit overlap, but we have had some people who've just joined this week, and I think it makes sense to start at the beginning of chapter 2 rather than, 1/4 of the way through. So we're going to look at how do you take information, data, and put it in the form of tables and charts that allow people to visualize what the information looks like. I guess there's a saying, a picture is worth 1,000 words. It's kind of that kind of situation. So I want you to imagine that we collected a whole load of data, and this data was ages of students at Olympic College. Now, when I collected data, can we pretend that I did it in order, and the youngest person was 16, and we finished with an 82-year-old, which could easily happen. And between here and here, there was 200 students. Now, I'm not physically going to write all 200 numbers down, but can you imagine that they're there, right? And they're in order. Now, if I just went to my head and say, well, I know you're interested in what the age distribution of Olympic College students are, right? How many young do we have? How many old? How many are over 50? How many are less than 20? What's the average age of them? Those kind of things. And if that's what my job was, you're in your business and that's what your manager would like to know. If you come back to him and said, here I go, here are 200 people's ages. There, I did my job. I think your boss would probably have a few choice words. Something along the lines of, that's not what I wanted. I can't tell nothing. I can't scan through 200 numbers and make any sense of it. Don't you need to somehow summarize that information? Put it in a format that I can actually see what the heck's going on. And one of the things that we do in that world is we create what is called a grouped frequency table. So that's the first thing we're going to look at. How do you make a grouped frequency table? Well, you have to decide some things before you go too far. And the first decision is a big one. How many, I'm going to give them various names because different textbooks will use different names. How many different categories do you want? How many different groups do you want? And if you're being a little bit technical, how many bins do you want? A bin is just a name for a group. So do you want this table to be like 8 rows, 10 rows, 4 rows, something like that? So let's suppose we decide that I want 7 rows. So I'm going to have 7 categories. Now I need to know the interval size. Basically, how many numbers are going to be in my 7 groups? Well, the way that you decide that is you find the largest number in your data, you subtract the smallest number in your data, and then you divide by how many rows you've already decided you want. And in this case, I have 82. I'm going to take away 16, and I'm going to divide it by 7. And in real life data, you don't get nice numbers. You're going to get some ugly numbers, and we'll have to deal with that. So 82 take away 16 is that guy. If I divide it by 7, I get about 9.4. Well, that's no good. Intervals should be nice whole numbers. So the rule here is you always round up. So that means my interval size is going to be 10. Okay. Are you comfortable about that? You're told in the book. So when you do the homework question, it'll say, I want 10 intervals, right? You know, I want 40 intervals. I want 6 intervals. And you will do this calculation. And typically they'll have a box and it'll say interval size, and you put the number 10 in. Now, how are we going to create this group frequency table using data from 16 to 82? Well, we're going to start by having age. Makes perfect sense. Doing pen color here. You don't write this red bit. This red bit is just the names of what I'm doing so that you're aware of what this is. This is called the lower class limit. And the guy next to it is going to be the upper class limit. Okay, so I guess I should put age up there. It makes more sense. Well, you start at 16-year-old, and you're going to have 10 different ages in that. So you've got to count your fingers, and this is weird. A lot of people think 16 to 26 is the first group, and they say, oh, 16 to 26 must have 10 ages in it, right? 10 different years. It actually has 11. I'll count with my fingers. 16, 17, 18, 19, 20, 21, 22, 23, 24. Well, let's 16, yeah. I'll do it down here. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. You see, that's 11 fingers if I had 11. So it's actually 25. So anybody who is 16 to 25-year-old counts and goes in this group. The next group is going to be 26 to 35. The next group's going to be 36 to 45. 46 to 55. 47. 65. And do I need any more? Oh, I do need some more. 66 to 75. And then the last one, 76 to 85. Now, let's see if that worked. Did I end up with 7 rows? 1, 2, 3, 4, 5, 6, 7. Do you see that the way that we approached that generated exactly what we were after? Not 6 rows, not 10 rows, not 8 rows, but 1, 2, 3, 4, 5, 6, 7 rows. So each of these groups, the lower class limit is called this number, the upper class limit is called that number. And you basically just have to make sure, I use my fingers a lot, that you get the first interval right. If the first interval is right, do you notice all the other ones? Whoa. There we go, just got it. All the other ones after that are 10, and all the ones finish 10 later. Now, what you would then do is you'd go through your data and imagine there was 200 numbers here, right? And you'd take all these numbers and you'd add up everybody from 16 to 25, right? So there was 1 16 and 4 17s and an 18 and a 22 and whatever it is. And we're just going to pretend that I've done that with real data. And there was 25 of these people. There was 35, there was 40, there was 50, there was 10, 60, 50. I get 50 to go, so 30, 15, 5. Let's see, I'll make sure I'm counting this up right. 50, 60, 100, 50. Yeah. And that's what we got. So if I said to you, looking at this, do you get a good idea or a better idea of what the ages of OC students look like? Can you see that we have quite a lot of young ones, 25 in this age group, but, and I know this isn't realistic, but I'm making this data up. Can you see in this case, that's a surprise. Oh, I didn't know we had that many 40 to 50s guys, right? It's not a surprise that I don't have very many old people, right? OC college students vary quite a lot. Do you know the students who take summer classes aren't the same age distribution as the ones that do day classes, fall classes? Have you any idea why there's a difference there? Why summer classes tend to have more adults and less younger students? What's your idea, Beckton? Have you got a thought?
Or why do you think they get more adults? Probably because kids want to experience
have a summer off.
Yeah.
A large majority of our very young students aren't you running start students, or at least students who like their summers. And so they don't typically choose, as some do, of course. There's always some that do everything. Whereas the more mature students, they're wanting to get through college as quick as they can, right? They can't, I mean, maybe they're family commitments and they have to take a summer off because of that, but most of them are more likely, at least, to take summer. Summer in particular is a lot smaller population anyway. A lot of people from every age group take the summer off, right? But when you look at the ones who do turn up, they tend to be more senior. And that's only a relative term, right? Now, in this group here, what age group, theoretically, I made this data up, but what age group has the most students? Not meant to be a trick question. Which age
46 to 55.
Yeah, that's a lot of the questions you're going to get in the homework are so, it can't be that easy, but they are. So you look at that and you say, oh, okay. Now, if I look at this particular set of data, I could do all sorts of other calculations. I could tell you, for instance, not a surprise, that the age group with the fewest number is the really old, right? And if you look really carefully, isn't there a kind of pattern in the way the data is forming? So very often, you will have an extra column added to the end of this data. And it's called relative frequency. Right, relative frequency, how do you get that? Well, the total number of students who took part in this survey was 200. And to get the relative frequency, for instance, of this group, you take 25 and you turn it into 200. And then you just convert that into, whoops, excuse me, you just convert that into a decimal. So 25 divided by 200, and as a decimal, you get 0.125. So 0.125. And then you basically go through all the others. I'll just do a couple. For instance, this group here is 0.25. And if I do the 5, the one at the end, and 5 divided by 200, that has a relative frequency of 0.025. So you'll get questions where your job is to fill in these numbers. Actually, you'll get questions where you have to fill this in, but the data set won't be 200. You know, it'll be 50 or so, or 40, something like that. Are you comfortable about how to create these? Imagine you counted these up and how to create that. Relative frequency is typically a decimal, but it can also be written down as a percent. So this would be 12.5%, this would be 25%, and this would be 2.5%. So that's essentially how you would create a grouped frequency table from a large set of data. So far, so good. Any questions?
So out of all that information, how would you compute the average age?
Well, you will find that out in question 3,
okay.
chapter 3. So yeah, good question. Not only will you have to find the average age, but you're also going to find in chapter 3 how to find the standard deviation, the median, and a whole load of other cool stuff, right? But
okay.
That's a different chapter. This chapter only deals with summarizing it in a table format or in a graph format. So the most common table format for this type of data is simply just going to be a group frequency table like this one, right? So are we comfortable how this would get created? It's a laborious job. I'm not kidding. It's a boring job, but it's, you know, it's a skill building exercise. So far, so good. Right, now, if you had this data, but you'd like to draw a picture of it, rather than a table, you'd like to visualize it, then what you would end up creating, which I hope you've heard this term before, is a thing called a histogram. Seen that term somewhere before? Because other subjects use statistics in their own subjects, right? I bet if you took a geography class, you'd probably see a histogram, or a social science class, you might see a frequency table or something. These types of things. Certainly, if you're in the medical field, eventually you're going to find out that some of the information that you're given will be in this format as well. So that involves us essentially creating a big picture called a histogram. Along the bottom, we're going to do ages per student. And the vertical one is typically the frequency. So this information here is going to be part of this picture here. Well, we have to do a little bit here. Histograms are basically rectangles where the height of the rectangle tells you how many, and the numbers in the bottom tell you the interval of values, in this case, the ages. But there's a little hiccup here. This is called the lower class limit, and this is called the upper class limit. I'm going to put it over here because I need the room. We are now going to add what are called class boundaries. I wish that little hole wasn't there, but this is going to be the lower class boundary, and this number that's going to be here is going to be the upper class boundary. And this might be a little bit awkward, but here goes. If I did 16 to 25 and then I did 26 to 35 and I was using a normal scale, and by that I mean a normal scale would be, right, you start at 0, you go, I don't know, 1, 2, 3. So there's 10, there's 20, there's 30, oops, here's 40, here's 50, here's 60, 70. Can you imagine I got 80 in, right? Bad planning. If you have your scale along the bottom, you have a big problem. 16 to 25, then 26 to 35. Isn't there a little space between 25 and 26? And histograms don't have spaces. They have to be rectangles that join together. So what you got to think of is what numbers in general, doesn't need to be ages, would end up rounding off to be that. Well, on one side it's going to be 15.5, that's called the lower class boundary. And then on the other side, it's 25.5. So I want you to imagine that I'm really good scale, and I would do something like this. You type in 15.5, and then you could do like 4 boxes or something. You type in 25.5, and then 2, 4, what do I need? 6. There's my scale. So 4, 8, 12, and 16. So from 15.5 to 25.5, you do 25 people. So you go up here, 25 is roughly about there. Then 25.5, which is where this one's going to start. It's going to finish at 35.5. You do your next group. So imagine it's about here. And that's going to be 35. So about here. And then I'm just going to cheat with the rest. It goes up like this. Then the next group goes up like this. Then the next group goes something like this. And then the next group goes something like this. And the last group goes something like this. Can you imagine I did this correctly? I'm just basically trying to do a speed thing. This is what your histogram would look like. And it's basically these heights using these boundaries. Now, when I look at this picture, I can see the same kind of information that's here. It's a little bit harder to read off the heights because the scales are so poor, but I can still get the same information. Can you see that this group here, which represents him, is obviously the biggest group, biggest age group? Can you see how it goes up and then it comes down again? It looks like that. So I'm going to do another one of these a little bit better than the one I've just did, but at least it's a start. Imagine that we have created, and as soon as I finish this, we'll do another histogram. Imagine that we've created some histograms, and we want to try and describe what we're watching, what we're seeing. Then there's some terms that you're going to get to use that describes what you're seeing. Right. Sometimes your histograms just look like a single mountain, right? They go up and they go down. Sometimes your histograms look like this. And sometimes your histograms look like this fella. When you are trying to describe a histogram, we have names for each of these basic shapes. Histograms that look like this, we say that they're symmetric. Basically, they look about the same, right? Either side. Have you noticed that this histogram climbs up, but then it takes a lot longer to, on the right-hand side? This piece of the shape, the bit that's here, is called the tail. And this shape is given a name. It's got an interesting name. It's called skewed to the right. And this is kind of the opposite version of that. Do you see how it tails off more to the left than it does to the right? This kind of shape is called skewed to the left. So you might get a question where you create a histogram, and then after you've created it, they ask you to describe it. Symmetric, skewed right, skewed left would be some of the terms you could use. This one here has another name. It's called mound shaped. So another way the question can be asked is, you might already have the picture, and then they give you like 4 choices and you pick the right one. So the 4 choices, one of them might be mound shaped. Second choice would be skewed right. Third choice would be skewed left. And the 4th choice might be something like uniform. I haven't drawn a picture of what a uniform histogram would look like, so I guess I'll try and squeeze it in over here. Have you any idea what you think a uniform histogram might look like? Just based on the name uniform. Derek?
Just a linear shape of bars, just straight across almost.
Yeah. You're allowed a little bit of wiggle, but, pretty much, kind of nothing much happening, right? Just they're all about the same, right? Uniform, like a person's uniform, they all look the same. A uniform histogram, all the rectangles look about the same. Now, there's bound to be little wiggles, right? Because that's real data, right? You don't expect every single one of them to be 10 high, right? That would be asking too much in reality. But couldn't one be 8, and one be 10, and one be 9, and one be 11, and one be 8, one be 10, one be 10, and one be 12, right? Just a little wiggle, nothing really in the pattern. And we call that shape, when it happens, uniform. The shape of a histogram can very often give you some underlying ideas of what might be going on. So imagine I collected all the scores that my students got in a quiz, right? And this is what it looked like. Which of the four major names would we use for a shape that looks like this one? Would I call it mound-shaped, skewed right, skewed left, or would I call it uniform? What would I call this?
Right.
What? Ah, now I can understand why you said that. But look really carefully here. Have you noticed it's where the tail is, not where the mountain is, that gives you the name? So isn't the tail on the left? See the tail here?
Oh,
So,
okay. So it's switched. Okay, I see.
Yeah.
I see. Okay.
But that's a good point, because that is a common mistake. People get, yeah, you think about where that is. Well, that is on the right-hand side, but shouldn't you be thinking about where the tail is? And that's where you get your name from. So this is skewed left. If that was my particular set of results, would that be an easy test, a hard test, or a kind of average kind of test? What would you probably base, just looking at that picture?
For average, it's
Okay, where are the most of the scores happening? Are they happening at good big scores, or are they happening at poor low scores? Big?
Big score.
So wouldn't this be an indication that this was probably an easy test? Because not many students did badly, and then a lot of students did really well. So if you are, this is the kind of shape that you probably would hope to get, right? Symmetric or mound shaped, where right in the middle is the typical student. Not so many did poorly, but not so many did well. Would have that kind of shape, right? And when you do tests or you do anything, you're probably wanting that to come out. And of course, nobody wants this. What does that look like? Well, that looks to me like a really hard test. Didn't a lot of people do really badly and very few did really well? And isn't it fewer and fewer did good as you travel up the scale? So you know, imagine you got nothing in the test and you got 100% in the test. You see that there are very few people who did really good. That would be a really difficult test. This here would be total opposite, a really easy one. So we are now going to do a second one of those creating a histogram. And after I've done that, I'm going to have a look. We're going to have a look at the homework and show you what it looks like when you do it in real. So we are going to set on my little table. I guess if I was doing it right, I'd have my, I'd have a whole set of numbers. So I'm just going to do some random things. 1, 3, 4, 4, 5, 7, 9, 11, 15, 22, 23, 27, 29, 29. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There. So this is going to be a very small grouped frequency table. So there's 2, 4, 6, 8, 10, 12, 14, 15, right? So I want to take 15 and I'm going to split it up so that there should be 4 groups. So imagine the question has already given us the data and they've told us that they want 4 groups. Okay, so let's find out how big the intervals have to be. You take the smallest and the biggest, so in this case 30, take away 1. You divide it by 4. That's 29 divided by 4. And 29 divided by 4 is 7.25. So how many numbers should be in each of my groups based on this value? 7 or 8?
8.
8. Great. This guy here is going to have our lower and upper class limits. So since the first number is 1, I'll just say 1, 2. Right, you want 8 numbers, so I just use my fingers. I go 1, 2, 3, 4, 5, 6, 7, 8. And this time, it finished in 8. Subtract those two. Don't you get 7? So it's still that one-off thing. Now, next group. Would you agree it starts with a 9? Now, what I tend to do in these is, once I've got the first group, I just use this number and keep adding it on. So that's going to be 9, add on 8, and finally, can I not count here? Went the wrong way. Darn it, I'm getting old. Oh, yeah. You have to go down to be safe, not up to be safe. So 1 to 7. Then it's going to be add on 7. Now we got the 8, which is where my brain was thinking. Then you got 15, then you got 22, and then you got 29. And then you get 14, and then you get 21, and then you get 28, and then you finally finish on 36. Now, a reason I knew that I was wrong there is, you see that that last group now is 30 in it, and I know I'm okay. So let me reiterate that. When you get your decimal, whatever that is, round down for safety. Okay, leave that guy blank for a minute. Let's do frequency. 1 to 7. 1, 2, 3, 4, 5, 6. There's 6 of them. 8 to 14. 1, 2 of them. 15 to 21. 1 of them. 22 to 28. 1, 2, 3. 3 of them. And lastly, 29 to 36. There's 3 of them. Now that's 8, 9, 15. That gives me a total of 15. And I know that this adds up to 15, so I'm happy I did that right. Okay, the boundaries. 1 to 7. That's going to be 0.5 to 6.5. This guy here is going to be 7.5. This guy here is going to be 7.5 to 14.5. 14.5 to 21.5. 21.5 to 28.5. And lastly, 28.5 to 36.5. Here I'll do relative frequency. And the first one, 6 out of 25, which is 0.6 out of 15, sorry. 6 divided by 15 is 0.4. Then 2 out of 15 is approximately 0.13. 1 out of 15 is approximately 0.07. And 3 out of 15 is 0.2 and then 0.2. Now, from this data, along the bottom, we can do whatever the data is. This is ages of people in the family. I'll do. Here is frequency. And the interval is going to be first one 0.5 to 7.5. And the scale 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first one goes up to 6. Then the next group is 7.5 and it finishes at 14.5. And it has a height of 2. Then the next group is 14.5 and it finishes at 21.5. That has a height of 1. Then the last two groups go to 28.5 and 36.5, and both of them are 3. Right, little hiccup at the start, takes about 15 minutes and it's done. Does this shape have any noticeable shape to it, or is it just a random look? What would you think? Does this histogram have any obvious shape to it? Because a lot of shapes don't. Acton?
Not really, but
Yeah, I would say not really. No shape. You don't need to have a shape. All that basically is telling me that this data looks pretty random, doesn't it? It could be anything. Let's see what this looks like when you have to do it in WebAssign, because that's pretty much where you're going to be living. Let me go back here. Okay, we got an issue with it's telling me the answers, which I do not want to see. That is a distraction. There we go. Someone go away. Right. So I'm now going to go in and we're going to look at what the homework looks like. This guy here. Can you see that clearly, or do you want me to make it bigger? Can you read what's going on here?
Yeah.
We're good? Okay. So they start off with a few questions to do with picking your intervals and can you use them or can you not, and so on. So let's see what the first one is. I found that a lot of the time for the early questions, I spend a lot more time reading them than I actually do answering them. The answer is very often quite quick. A data set has values ranging from as low as 10 to as high as 52. What's wrong with using just those limits, those intervals? And there's 4 choices. One of those 4 is the correct answer to why, or what's wrong with using only those intervals.
Are you looking for the answer?
Yeah.
Oh, okay. It's gonna be the first. The first one.
Yes. Oh, it sounded like a rhetorical question. No, it was a real question. Which one is it? Yeah, so let's read. Each data value must fall into one of these classes, right? The data value 50 or anything above that doesn't. Now, do you see that this group here finishes at 49, doesn't it? But isn't the last data that at least we know of is 52? Do you see it wouldn't work? And you have to make the assumption that that's the last interval that you're going to be able to use. So that's what's wrong with that one. Right, here is a set of data. The low value is 20 and the big value is 81. And it's going to have 7 groups, right? 7 classes. So although you can't see what I'm doing here, don't we have to figure out what the class width is? That means how many numbers are going to be in each group. Well, the calculation for that is big number 89, take away the small number 20 and divide by 7. And I'm doing that in my calculator and I'll tell you what it says in a moment. And it's 89, take away 20, and then you divide it by 7. And the answer that I get is 9.08 and some stuff. So where are we going here? 9 or 10? Bear in mind 20. Won't this guy be 30? This guy be 40? This guy's 50. Going up in tens. This guy's 60. This fella is 70. And finally, this guy is 80. What number will this one be on the upper class limit? 20 to what number? 20.
29.
Yeah, got it. And now that I see this interval, doesn't that look like a very nice kind of natural limit? It just has a really cool flow to it. And we are done. And just to double check, almost like magic, didn't the last interval contain 89 in it? So we know it matched. Okay, so suppose your smallest number and your largest number. And then I tell you how many groups. And here is going to go the answer. And the answer is going to be the interval size. So suppose I have data and it starts at 5 and it finishes at 29 and I want 4 groups. So that'll be my first question. And I'm doing the questions first before I even go near the answers. I have my first number is 1. My last number is 221. And I want 10 groups. And my last question is, I'm going to start at 15, finish at 53, and I want 8 groups. So for each one of these questions, we are only going to do essentially step 1, right? How many numbers should be in each group? So let's see how that one works. For the, I'll call them questions 1, 2, and 3. For question 1, you take the largest number, you subtract the smallest number, and you divide by 4. In this particular question, let's see what that looks like. So 29, take away 5, divided by 4, you get the answer 6. Well, that's good news because I don't need to worry about rounding off, right? I got a perfect answer. That's not going to happen for number 2 then. The biggest number, take away the smallest number, divided by 10. And let's see what that looks like. It's 21.1. Now I'm going to get it correct this time. In any situation where the answer is a decimal, if you want to be safe, do you round down or round up? And it's always the same thing. Each time you round up.
Yeah.
So finally got it right. So in this second one, the answer would be your group should have 22 numbers in it. Pretty ugly looking group, but that's what you do. And for the last one then, it's going to be 53, the biggest, take away 15, the smallest, and dividing that by 8. So I'm going to go 53, take away 15. I'm now going to divide it by 8, and I'm looking at 4.75. So again, wouldn't you round up, and your interval should have 5 numbers in it. Now you notice in this case, it was still rounded up, not rounded to the nearest number, but rounded up to be safe. In this case here, it is rounding up, isn't it? In this case, we didn't have an issue. Are we clear, since I confused you, how you decide on the size of that group? Do you feel comfortable now about the right thing to do and how you get the answer?
Yes.
Right, so I hope I've cleared that hiccup up. Now, since I do have this kind of table in front of me, let's use that table to figure out just what the first interval would be. Not the whole table, that would take forever, but just the first interval, right? So for the first interval, you start with 5, agree? This is question 1. And it's going to have 6 numbers in it. So I like using my fingers, right? 5, 6, 7, 8, 9, 10. You agree that's got 6 numbers, right? 5, 6, 7, 8, 9, 10. Now look at that group carefully. If you subtract those 2 numbers, don't you only get 5? But doesn't it still have 6 numbers in it? Because the 2 guys in the end, right, they count as well. I'm going to do the second group. You start at 1. A weird number. You probably run out of fingers pretty quickly. What would be the finished number if you wanted 22 numbers here? But you do have a bit of luck here. It does start with a 1, doesn't it? So that's my question. What's the second number in this first group?
23.
Oh, so close.
24.
Oh, the wrong way. 22. Now, you might say, wait a minute, why does that finish with 22 and that doesn't finish with 11? If you subtract these 2, how much do you get?
21.
And then add 1 more. If you subtract these 2, how much do you get? 5. Then add 1 more. Do you notice that the difference plus 1 should always equal the interval size? So if it's a really ugly number, right, like 22, take the first number and add 1 less. So 1 add 21 gets you 22. 5 add 5 gets you 10. Right, this is 15. This is the last one of this group here. You're starting at 15. I guess I could use my fingers, couldn't I? But if I'm doing this other row, wouldn't you do 15 add 4 and wouldn't you get 19? And let's check that out. 15, 16, 17, 18, 19. Exactly what it should be. Are we comfortable now about if you know the smallest and you know the interval size that you can create the first group? Start with the first number and then use the interval size to figure out what the second number in the group would be. Now, what are called the class boundaries? This is the class limits. These are called the class boundaries. These are a little bit easier to do. You take 0.5 away from this number and you add 0.5, you add 0.5 to that number. Take away 0.5 and you add 0.5. Take away 0.5 and you add 0.5. And the only reason we need these class boundaries is because those are the guys that we need to use when we make our histogram. You see the guys that go here? It's the class boundaries that tell you the start and finish of each rectangle in your set. I should tell jokes at the start of today. Maybe I'll make less mistakes. Are we comfortable now to get class limits and class boundaries? Do you feel you know how to do the first one, right? Now, once you've got the first one, don't you just use a pattern to get all the others that come after it? Because it's basically keep doing the same until you finish. And if you do it correctly, shouldn't the last interval always have somewhere inside it the biggest number? Right? It might be at the beginning, it might be the middle, it might be the end, but somewhere inside it. If it didn't, like the mistake I made earlier, won't you know it? Because the last interval will be short. Hey, I need an 89, but I finished at 87. That's not right. That's always a good sign that you screwed up like I did. We ready to take another look at homework question? Okay, I'm going to get one set up here in a moment. Let's see which one we'll do. Yeah, we'll do this one. I'm going to be doing question 6, so hopefully you can keep your eye on me because, strange as it may seem, I have been known to make mistakes, haven't I? So, this particular set of data comes from, well, it's actually real data. It comes from D.P. Mayer's Journal of Urology, volume 10, and then these are the pages. So this is true data. It's not just me making up numbers. And if you want to know where this data comes from, certain kinds of tumours tend to recur. The following data represents the length of time in months for a tumour to recur after chemotherapy. So you've got some kind of tumour, a cancerous one, I'm supposing, based on the chemotherapy, and you killed it, and it's gone, or at least you think it's gone. And in this poor guy's case, 1 month later, the bloody thing was back again, right? Although there's a guy who almost lasted, 5 years before his came back. Now, let's put some good data to this. Do you know there's a whole chunk of people you killed it once and it's gone, right? It's your cure, no relapse, anything. So these are people who get a tumour, how long it takes them to get one. And this is kind of the data that could be quite useful because if someone has this tumour and it's a particular kind, and you're the doctor treating that student, that particular patient, and you're going to say, well, okay, we're hoping that everyone's going to end up fine, but when you look at this data, shouldn't you keep checking just to be on the sure side for probably at least 6 years? Because in one case, didn't it take almost 6 years before, or 5 years, I should say, right? Almost 5 years before it finally appeared. So anybody who's ever a family member who's had a tumour, a cancerous episode in their life, they don't just take care of it and say, oh, that's it, you're fine, we'll not bother with you anymore. Don't they have yearly checkups or 2 yearly checkups or whatever it might be? Depends on the type of cancer. So we have got good data here. The first question says, find the class width. Well, it would be really nice, but they didn't do it. Wouldn't it have been really nice of them if they put all that data in order so we could find it? But I'm telling you, I know the smallest number, it's 1. What's the biggest number in that list? What's the longest time? That's the question. Agreed. So if you, this is what I'm writing down. If you take the biggest, take away the smallest, and you're being asked to do what, 5 classes, then I'm doing this on my calculator, so you're just going to trust me on this. 58 divided by 5, I'm looking at 11.6. For safety, how big do you make your intervals if the decimal difference is 11.6?
12.
12. Are we all getting now more comfortable with the rounding up rule? Okay, so you just simply type in 12. Right, now we're going to do the first class limit. So you start at 1. Of course, I need a number to finish with, don't I? And it has to have 12 numbers. So I guess if I count with my fingers, would you agree that 1 to 12 has 12 numbers in it? You may have to use some toes, but it's done. And won't all the other numbers after that basically just be add 12, add 12, add 12 to the end? So I'm going to do that because I kind of need these numbers to keep going. So there's add 12. Can I do a tab on this? No, I can't. Okay. Add 12. Add 12. And finally add 12. Over here, oh, this is easier. This is the 12 times table. Now, the moment of truth. Does that last group contain the biggest number? Yes?
No.
What's the biggest number?
59.
Right, does 40, 90, 60 contain 59?
Pardon?
Is the group 40, 90, 60, does 59 fit inside that group?
Yes.
Yeah, that's what I'm asking, right? It doesn't need to be the last number, it just needs to be in the group somewhere. Right? So that's a good sign that I've done this correct. And the class boundaries, well, the first one would be 0.5 and it would finish at 12.5. I'll do one more of these. This one would start at 12.5 and this one would finish at 24.5. And can you imagine I did the others? I just don't want to. Let's do frequency. I'll come back to some of the stuff that's missing here. I do need a lot of help here because my scanning's not great. If you go through this set of data, I think I should make this a bit bigger. Let's see if I can do that. Yeah, that helps me a lot anyway. Right. How many numbers are between 1 to 12? Right, including 1 and 12. How many numbers are in that group?
Oh, sorry. I didn't already count it.
5.
I agree, 5. I want somebody to agree with me when I get an answer. That way I'm happy with putting in. Okay, the next group is 13 to 24. We just have to fight our way through this. 13 to 24. 13, no, I'll count that one. That's 1, 2, 3, 4, 5, 6, 7, 8. I get 9. But if you got different, tell me, because I could have missed one or counted it twice. I think there's 9 numbers between 13 and 24.
I got
Yeah, I got
8.
9.
Okay. I guess I'm wrong.
Okay. It's dead easy to screw this up. So if you got 9, that's great. But I'm probably just lucky. Has anybody thought ahead and told me what the next group is? In fact, while you think about 25 to 36, I'm going to look at 46 to 90, right? I'll do that one. And if somebody else wants to do 37 to 48, we can get this over with quickly. So I'm doing 40, 90, 60. You pick some of the others. 1, 2, 3, 4, 5, 6. I make it 6. Anybody got 25 to 36?
I got 4.
Okay. Does anybody else get 4? Well, one's better than no data, I guess. What about 37 to 48? Has anybody got that one? I think that's probably going to be the biggest group, is it?
I got 13, I think.
13, I think. Anybody got a 13? We'll call it 13. And any different number?
I can count again.
I got 13.
Okay, we're cool. Right, so I just did a quick check here. There's 7 numbers in a row and there's 6 rows. So that means there's 42 numbers. So this is what you would have to do as well. Shouldn't you count up the frequency and it should be 42? So I'm going to cheat here. See if it's not 42, I'm randomly going to pick a number and give it some extra, right? Just to pretend that it's right. If I add these together, you get 14, 18, 28, 31, 37. God, we're 5 short. That's a lot. Okay, that's an awful lot. Okay, I know that's not true, but we can pretend it's 18, right? Just so we can move on. Moral of this story, it's hard to do, isn't it? It might be, this is how I would do it because I'm really bad at counting because of my scanning. Couldn't you print that page out and then just get a pen or a pencil and cross the damn thing off each time you used it so that you only would be looking at fewer and fewer numbers each time and you're less likely to miss it. But let's suppose that by sheer luck, that's actually correct. Well, that's how you get frequency. Now we've got relative frequency. So 7, 1, 2, 3, 4, 5, 6, that's 42. So 5 out of 42. And I'm about to do a mistake. 0.119. Doesn't look like a mistake, but it is. And the mistake is 2 decimal places.
We just round
And
it.
yeah, well, I should have called that 12, shouldn't I? And you might say, but my answer's better. Well, your answer is better, but it's not the answer they wanted. So if it wants 3 decimal places, give them 3. If it wants 2, give them 2, because this software is not flexible. If it wants something, it has to be that something. It's not intelligent enough to say, well, 119 is even better than 12. I'll let it slide. It won't. So I'm going through the next few just so we can finish this guy off. 9 divided by 42 to 2 decimal places is 0.21. 4 divided by 42 is 0.095. How do you round 0.095 off to 2 decimal places?
0.95.
Well, that's got 3 decimals, so you can't.
Oh, I think meant 0.
Right. So 0.095 becomes 0.10. Because you round up 0.09 and you get 0.10. That's a funny one. 18 divided by 42 gets me 0.43. And last but not least, 6 divided by 42 gives me 0.14. Now, every time I do anything, I try and see if there's a check. The check for this one, the frequency, is that they should add up to 42. The check for the class limits wasn't it that the last group needs to have 59 in it. What's the check on the relative frequencies so that I know that I've probably done them all correctly and not maybe screwed up a little bit? What should they add up to? That's the question.
100%.
1. Yeah.
1. Now, I'm doing a quick scan through this and it does actually add up to 1, so that's a great sign. So I feel comfortable. But you have to be a little bit flexible on relative frequency. Do you know sometimes if you round off to 2 decimal places just by sheer bad luck, more numbers get rounded up than get rounded down? So your answer could end up being 1.02 or it might be 0.98. That's okay. If you see that, it's a good sign that everything's fine. Now, we haven't touched on these 2 guys, so let's finish with these 2 guys. Cumulative frequency is a term I've not used yet. So here goes. The first number is 5. Cumulative just means, like the word accumulate, it means things are being added to other things. Things are being added together. So this one here, the second group, the cumulative frequency is now 14. And the next group, it's 18. The next group, it's 36. And the last group, it's 42. So do you see how you find the cumulative frequency? You just add those two together to get 14. Then you add these 3 here together to get that one. And the last one, you add everybody together. And here's the check. If you do it correctly, shouldn't that be 42 people? Right, one last guy in this table and it is done. It's called the midpoint. If you've done Math 99 or Math 94, you've probably seen the term midpoint. Doesn't it mean the middle of 2 points? In the middle, midpoint. Right, if you want to calculate it, take these two numbers, add them together and half it. And so the midpoint is 6.5. You want to get these two, you add them together and half it. And you should get, let's check that out, you should get 18.5. And the next one, 30.5. And the next one, 42.5. And the last one, 54.5. Do you notice I didn't actually do the last 4 calculations? Although they are correct, that is the midpoints. Have you noticed that there's a pattern in the midpoints that seems to be a pattern that happens a lot in the first half? Do you notice that these numbers always go up in 12s? Don't the end class limits go up in 12s? Don't the class boundaries go up in 12? Do you notice that so do the midpoints go up in 12s? So if you want to save yourself a little bit of work, just find the first midpoint by adding the 2 class limits together and halving it. Suppose I added the 2 class boundaries together and halved it. Would that also get you 6.5? Yeah. So that's it. Right. Now, here is 4 histograms. So the good news is you don't actually draw many histograms. They give you 4 pictures and you pick the right one. So I'm going to have to shrink this down so we can actually see the choices. Here is our 4 frequencies. Here is the table where that information is coming from. One of these 4 pictures, but only one of them is right. Now, if we'd filled in the data correctly, we would have been able to pick the right one. But I'm pretty sure, and it's not just me, I'm blaming you lot this time as well, because it's a fiddly job, right? We should be able to figure out which one of these 4 it would be. And let's just pretend I know the answer, and I pick that one. Then you just put a little dot mark, and you're doing it. And if you want to do a relative frequency diagram, don't you just take these numbers and use them, in which case it's probably that one. The terms that I've used today, most of them are here except this top one. So let's look at it. If my data looked like a big hill, right? If these histograms were started low, built high, went back down again, right? Something like that. Then we would be able to say that it was mound-shaped, right? Symmetrical or mound-shaped, right? It might have been skewed left, it might have been skewed right, it might have been uniform. The only one that I've not done and described is a histogram can be bimodal. Bimodal. I wonder what that looks like. The word bi is, I think it's Latin or Greek, I can't remember which, but it's the same root word that is used in things like bicycle, bisexual, binary, you know, the words that have that bi sound at the beginning. Doesn't it typically mean two? So bimodal just means your data has two hills in it. So if you did a histogram and it looked something like this, and there were obviously two distinct separate hills, you would say that that shape was bimodal. Does the name kind of make more sense now you kind of see where it's coming from? It's got two modes, it's got two hills. I guess if we were using that word today, we might say two hill or something, right? Or bi hill, right? Or something weird like that. Okay, any questions apart from the fact that this takes forever and a day just to do one question? Right? Do you feel comfortable about the processes of creating a group frequency table, and then from there, what a histogram might look like if you drew one using that data? That's pretty much really the theme so far for today. So far, right? If there's no more questions on that, I want to start our last topic for today. Is there any questions? Are we good?
Professor,
Yes.
the homework we've been together, I checked the answer. The
Yes.
frequency and relative frequency and cumulative frequency is all wrong.
All these guys? Yeah, it wouldn't surprise me because we were about 6 out when we counted. And another, yeah, it's not that we did anything wrong. We did correct with the numbers that we had. So that is probably why nothing worked, Gary Young. But I was really dubious about that 18, wasn't I? I just chucked a whole number into that one. The chances are that we're wrong all over the place because of that. But you're right. It wouldn't surprise me that we were wrong. Okay. So, who's the last guy for today? Going to be, well, we're going to create a, let's get, excuse me. We're going to create an ogive graph. It's sometimes called a cumulative frequency graph. And let's look at how that would work. So I'm going to just take a whole load of data that has been created, and we're going to go straight into the drawing part. So over here, let's suppose I have, and we'll have a very small data set because I don't want to do this forever. I'm sure you don't want to either. So let's suppose that we collected some data on ages again, because I have no imagination today. And we looked at the ages of people who lived in a street, and we got brand new babies up to 9 years old. And then we did 10 to 19, 20 to 29-year-olds, 30 to 39-year-olds, and because I want this to be a very small table, nobody old lived in this street, right? Just to make the live data. Now, so you've got this data. You're going to do the boundary one. So in this case here, you'd go, change color. You'd go 29.9 to 39.9. This guy here would go 19.9 to 29.9. This one here would go, and why am I saying 0.9? 0.5s. This one would go 9.5 to 19.5. This one here would go 9.5. And here's the funny one. What would you get if you take 0.5 away from 0?
-0.5.
Yeah. I know that is weird, but that does happen. Now, we are going to have here frequency, and then here we're going to have the cumulative frequency. So let's suppose it went 3, 5, 8, 4, right? Then what would the cumulative frequency look like? The first one would be 3. The next one would be 8. Wouldn't the next one be another 8? And then the next one would be another 4. Are we comfortable that you could take some data and create one of these tables? Now, I haven't bothered putting in relative frequency. I haven't bothered to put in midpoints because for this question, you don't need them. So I didn't want them. So to get this ogive fella, this cumulative frequency is another name for it. You have a vertical axis, which is going to be your cumulative frequency. Now, the biggest number I need is 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, of course, 20. There we go. Along here, you are going to have the age group. And we use the class boundaries. So I'm going to start at a funny number, -0.5, and then I'm going to go 9.5, 19.5, 29.5, and finally 39.5. Now you can just make sure that the gaps between them are the same and that scale will work fine, even although it's downright weird looking. Now, the scale here goes, one box is representing 1. So I won't put all the numbers, but there's this guy. At the first value, at -0.5, you put a dot at 0. So at this fella here, whatever this fella here is, in a cumulative frequency table, that guy is always 0. And then the next number is 9.5, you put the 3. The next number is 19.5. So you notice now that I'm using these numbers here with these cumulative frequencies. So pretend that's totally missing now. Take that out of your brain and just look at these guys. So 9.5, you get a dot at 3. At 19.5, you have a dot at 8. At 29.5, you have a cumulative frequency of 16. And at 39.5, you have a cumulative frequency of 20. And then what you do is you basically just, oops, you join them together. And that is a cumulative frequency or ogive graph. Are you comfortable about how I created, just over a little bit, how I created from this, that? The first number gets 0, and then all the class boundaries are used after that. Any questions about that fella? Oops, there we go. That's what I was trying to do. I'm not sure. I hope that's a good sign. Well, before you go, I want to show you a little issue that you need to be aware of on doing your homework and WebAssign. Okay. Can we, are you looking at a grid right now, a square paper, right?
Yes.
Can you imagine that these are the numbers that you're going to have along your x-axis, these are the numbers you're going to have in your y-axis, and we are going to do our scale. And let's pretend that I have my data. So the first one's going to go there. So you click on this fella, and you see those dot to dot thing. You click on that, and you go, I want to go from there to there. And then your next one, you want to go, you do this again, and you say, look, I want to go from there to here. So you can see what I'm doing is I'm plotting the dots and they're joining with lines. Now, I'm going to make a mistake for the next one. I'm going to go from there to there. Now, do you see those two dots don't match? That's called segment 1. This is segment 2. This guy's segment 3. So if I go to segment 2 for a minute, can you see these are the coordinates of the points? So this one here finishes at 35.5, 17. So when I go to this one, shouldn't this guy be 17? Now when I click out of that, or even before I did, do you see how it's fixed it? Now it's very difficult on a scale like this to get some of these dots exactly in the right place. For instance, see how this one here says 48.27? Maybe it shouldn't be 48.27, right? Maybe this guy should have been 48.527, right? Well, now do you see, you can tweak each of your line segments by just writing down what the X coordinates should have been. And as long as you nose to tail them, right, start to finish, same start, same finish, you can actually do all of them. So I might as well finish the last one. Let's say it starts here and it finishes up there. Most people, when they draw an OGI curve, right, just like I've done here, you have to do it on the software. And that tends to be the one that causes the greatest amount of grief, because it's a little bit fiddly. Would you agree it's quite fiddly? Now, I don't know if you can see it because it's very faint, but if you put your mouse pointer over a dot, it'll tell you the coordinates. So you'll know if you've got that one in the right place. There we go. Now, if I keep my mouse pointer on that dot, do you know that I can actually move it around a little bit? And so if I thought, oh, wait a minute, it should have been a little bit higher, I can then put my mouse pointer on this one and fix it. So you can tweak it as you go along. So maybe you'll put it in roughly in all the right places, so you've got something to work with, and then you'll tweak it so that everything starts and finishes at the exact numbers it's meant to. And because when you're finished with the question and you hit submit, WebAssign had like, this is what the answer should be. This is what the graph should look like. And these are the points where they should be. And you're not even allowed to be a 0.5 out. If it should be at 3.5, 9, it must be at 3.5, 9. 4, 9 won't cut it, right? It won't, it'll just say you're wrong and you'll lose out of it. Are we good?
Yeah.
Right. I think then we should finish with a joke. I think I started making fewer mistakes roughly about halfway through. Still make my usual number, but at least not the first one. So jokes are working for me right now. So has anybody got a really corny bad joke that they want to tell us before we leave?
What do you call a priest, or what do you call it when a priest drinks too much communion wine?
I don't know.
Trans substance abuse.
Oh God, that is subtle, right? Oh, before you go, I'm forgetting things all over the place. When do you know, hopefully you know there's a chat box down the bottom. If you go to the chat box and click on it and just say hi, I use that as an attendant, so I know you've been here. So if you go down to the chat and say hi, hello, whatever you want, just something that will register your name, I should be able to just check that off and you've got your attendance, which you want for participation, right? Because 20% of your grade is for participating. And I've got everybody, I think. Yeah. Jillian? Yep, got you. Bailey, are you here? Yep, sorry, you're here. Everybody's here. We're cool. Well, that's it for today. I think we've reached a kind of natural finishing point for today. I'll see you on Thursday. It looks like this group Tuesday, Thursday time schedule works best for you, right? If that doesn't work for you, if you're finding it kind of awkward, I have a Monday, Wednesday, Friday, and I guess you could do a bit of A and a bit of B, you know. If Thursdays work for you but Tuesdays don't, you could turn up, you know, Monday, Wednesday, Thursday, that kind of combination, and you would definitely get probably more than you need, but that's better than not enough. That's it. Bye-bye, guys.
I have a question.
Bye-bye. Were you asking something there, Gary Young? I didn't catch what you said.
How many attempts can we get from homework?
3.
3? Okay.
Yeah. So, see that one that you told us that was all screwed up? Have you got the right numbers for it now?
Not yet. I just want to make sure that how many attempts can we have?
Yeah. Also, when you look at it, there's other things like show me another example or give me help or some little, have you noticed that some of the tabs have videos as well that you can hit? So, I mean, feel free to use any of those features if they help you get over a hiccup in a question.
Okay.
Okay. I forgot to ask you before you go, Gary Young, what's your baby's name again?
What?
What's the baby's name?
Acacia?
Acacia?
Yeah. Acacia Rose Heart.
Oh, any family connection or you just like the name?
Acacia is Matt's sister's name, and
Right.
Rose is mother-in-law's middle name.
Didn't you want to chuck one of your mum's name in or someone else's name along with the group? Have a triple name thing?
No, she has a Korean name, so.
Oh, she has a lot of names then.
Yep.
So what is it, if you want to share, what's her Korean name? Is it a translation of her European name or is it a totally different name?
Totally different. I just created her name.
So what is her name?
Hannah.
Hey,
Her Korean
Hannah?
name is Hannah. Yes.
Hannah. That's cool.
And following my last name.
Gotcha. Okay then. Well, I'll let you get back to your baby and your homework, and hopefully things will go smoothly
Thank
and we'll be
you.
fine. You're welcome.
Okay.
Bye-bye.